Hello everyone, hope you're doing well. So in this lecture we are going to discuss about calculation of number of moles. So mole is something most of the students are very scared of. I think it's just the unnecessary hype. It's very simple to understand. So today we are going to discuss on a very basic level. So why do we need to calculate these number of moles? Why it is so important. We give symbol number of moles with a small n. So we'll basically discuss about this number of moles, but let's try to understand what mole is. So mole specifically comes from a Greek word and it means massive heap. That means the number we are talking about is quite big enough. So now moles in chemistry language, it's a quantity. So mole is just like we try to you can say measure weight in kilograms. We try to measure distance in kilometers, meters. We try to calculate time in seconds. So similarly, we have something related to the atoms. The quantity we call it as moles. So, number of moles we can calculate in the entire universe. We can calculate, which I believe are number of moles also. There's a way to do that. So, we can calculate number of moles of anything in the entire universe. So, that concept is something very nice. It's very helpful when it comes to laboratory chemistry, practical chemistry. So, without this, we can't go to the next level of understanding concentrations in chemistry, which is very much important from the solutions chapter point of view. So, number of moles is very much essential. So, you imagine if you have a glass of water filled uh, in front of you. So, you know roughly that this glass of water will be 200 ml. So, in those 200 ml, if you want to calculate how many atoms are there, so this is how this number of moles is going to calculate. Not only atoms, if you want to calculate the total number of electrons, if you want to calculate the total number of uh, protons, neutrons, anything we can calculate with the help of this concept. So, mole, I'm not defining you can say, the book definition over here. What I'm trying to help over here is to understand how to calculate number of moles and how to apply in various numericals. So, calculation of number of moles, the very first thing we calculate with respect to mass. Then the second calculation that we do is with respect to number. And the last is with respect to volume. So we'll take these concepts one by one and we'll try to link all these three. These are very much interrelated. Please keep an open mind over here. So when we say calculation of number of moles, with respect to mass. Now the mass that we are talking over here is the same mass that we discussed in 1 to 20 atomic number, individual element masses. So we say it's a concept. 1 mole of any element is equal to its gram atomic mass. So what is gram atomic mass? That is nothing but atomic mass expressed in grams. So if I take my favorite sodium again, 1 mole of sodium. So its atomic mass we know that is 23. So gram atomic mass is expressed in grams. We are just changing the unit. So if I'm standing in a lab, we have 23 grams of sodium. Definitely, it's very risky to even keep sodium outside. It can react with, it's highly reactive. It can react with oxygen, and we should never put it in water. Though it makes a sound like a firecracker, but still. So if we have 23 gram of sodium in the lab, that quantity is something called as 1 mole. So if we take 2 mole of sodium, this will be 23 into 2, 46 gram. Similarly, 3 moles, 4 moles, 5 moles, you can just keep on calculating. This is going to be our standard. 1 mole of sodium is always going to be 23 gram. If you increase the mole number over here, number of moles, 2 moles, 3 moles, 2.5, any value. So the mass, gram atomic mass will be multiplied into that number. So now if we talk about any molecule or compound, so 1 mole of, I'll take molecule over here, is equal to its gram molecular mass. Now what is gram molecular mass? So it's molecular mass expressed in grams. So first we need to understand how to calculate molecular mass. So I'm going to take an example over here. So we are going to talk about carbon dioxide, CO2. So carbon dioxide. So one atom of carbon dioxide means two oxygen atoms. Now carbon mass from the previous lectures, if you remember, it's 12 mass. You need to take a sum. Like you can say you need to take a sum of all the masses in a molecule, and whatever number of atoms are there. Like oxygen, we can see we have two atoms. So we need to multiply with its individual mass. So oxygen is 16 that we discussed previously into the number of these oxygen atom into 2. So if you sum it up, it will give you 44. Now if we are not expressing this molecular mass in grams, we can write as small u. AMU, if you remember from the previous class, A dot M dot U, that's how we express the unit of, you can say, atomic mass. So if it is not U, we can write as 44 gram. 44 gram is something called as our gram atomic mass. Gram molecular mass. So now if we take another example, 1 mole of carbon monoxide. This will be equal to what? So carbon monoxide is, carbon is 12, 12 plus 16, that is going to be 28 grams. So this is not going to change. So if we take any other molecule in the lab, so 1 mole of any molecule is equal to its gram molecular mass. Now this is standard. So 1 mole is staying the same, but the values for different type of compounds, elements, that is changing. So we need to keep in mind 1 to 20 masses, and if we are talking about any other compound or any other molecule, then we can refer it from the periodic table. Like post 20, we can refer it from the periodic table, and in most of the cases in questions, they will give you in the brackets what are the mass numbers of these elements. So now one more thing, this is one expression. This is one expression. The same expression has been used in the chemical formula. So this formula is number of moles given by small n. Now do remember one thing, small n in chemistry has multiple meanings. Small n can be the number of orbit, n. Small n can be the principal quantum number. Small n can be used in your empirical formula as a common factor. Then small n is a number of moles. Small n in chemistry has multiple meanings in different circumstances, but over here, small n is a number of moles that is equal to given mass or weight divided by gram atomic mass or gram molecular mass. So you can write the short form of this gram molecular mass as GMM, gram atomic mass as GAM. You can write the short forms also. So given mass can be small w, given atomic mass, or you can say gram molecular mass can be written as mw. So you can remember n is equal to given mass divided by mw. So this is our formula. So if we are going to do one question, a very simple question. Before that, please remember units of number of moles. So we write it as MOL. We never write it as MOLE. We never write it as MOLES. It's always going to be MOL. So if we have to do one question, calculate the number of moles in 88 grams of carbon dioxide. So I'll do it both in both ways in the unitary method. Like I call this as a unitary method. Like 1 mole has this much, 2 moles will be what? So crisscross method. So or you can do with the formula. So calculate the number of moles in 88 grams of carbon dioxide. So how we will proceed? 1 mole of carbon dioxide is equal to 44 gram. Now how do I know this? We just calculated a minute back carbon dioxide. So 88 grams will be equal to how many moles? So 1 crisscross, we call this as criss, 1 divided by 44 into 88. This is like simple maths we are doing over here. So this will be 2. So 2 mole is our answer. It's a very simple calculation. So if we are going to discuss these kind of simple questions, so this is one unitary method or number of moles formula based. Given mass divided by molar mass. Given mass is 88, molar mass is 44, that is a gram molecular mass. Again we will get the same answer, 2 mole. So whether you follow with the unitary method or you follow with the formula, it's always going to be same, because we are doing right now simple questions. Sometimes in complicated questions it's better to go with the unitary method. That's always best. I like this concept best. Okay, but you should know about the formula for sure. There's no harm knowing about it. Then if we go to the next calculation, calculation of number of moles with respect to number. So now what is this number we are talking about? So this number can be any number but not number of moles. Now most of the students get confused about how to apply these. They get confused. Okay, number of moles is asked, number of atoms, how to it takes some time to process in your brain. But it's okay. We'll go through that. So now in this we say 1 mole of any element is equal to 6.022 into 10 to the power 23 atoms. Now, how this number came into action? This is very famous Avogadro number from the scientist named Amedeo Avogadro. Now, in some books, they write 6.023 into 10 to the power 23. So, it can vary a little bit, but whatever your books follow, you can go ahead with that. 6.02223, or in a round figure 6 it's written, it's okay. But 10 raised to the power 23 is something very common in all the books that they cannot change. Now, what do you understand by this statement? 1 mole of any element. So we are going to the next step. We discussed, okay, in the lab, if we have 23 grams of sodium, that quantity is called as 1 mole. So if we have 46 grams of sodium, that is called as 2 mole. So that's how we are calculating. Now, in that 23 grams of sodium, how many atoms are there? So it's always going to be Avogadro number, 6.022 into 10 to the power 23. Now, why this number? How this number came in? First, we will discuss about that. Now, I'm going to take carbon. Now, most of the time when they're discussing mole, they always consider carbon because it's taken as a standard. So, one carbon atom is roughly equal to 1.99468. You can elaborate that number. I'm keeping it as 1.99 into 10 raised to the power minus 23 gram. This is roughly the weight of one carbon atom. Now, if you think how they have calculated, so there are spectroscopic methods to calculate the single atom mass or weight. So we know carbon gram atomic mass is 12 grams. So 12 grams will be equal to what? So 1 divided by this number. This number will go over here. So in 1.99 into 10 to the power minus 23 into 12. So crisscross method, the unitary method. So this is roughly equal to 2. So if you divide it, so it will be approximately 6.022, and this 10 to the power minus 23 will go up and it will become just 23. Not, I'm not writing plus 10 to the power 23. Atoms are present in 12 grams of carbon, and this whole thing is considered as 1 mole. So now this is about atom. This is about carbon atom. So how can we prove it for all the elements in the periodic table? So remember one thing, every element has different number of protons, neutrons, electrons. So this weight will be changed. You can take, you can search online what's a magnesium atom, one single atom's weight. Take that value, then again, do this 1.1 divided by the value of magnesium atom and into its gram atomic weight, gram atomic mass. That is for magnesium it's 24. So point over here is that this value is always going to be different for different elements. For different elements, and even the gram atomic mass will be different. But when you divide them both in this format, it will always give you this constant value. This will be same. So what do you do in physics and chemistry? You run some different experiments, and if you get a constant value in every experiment, we consider it as a constant. We experimentally proved it. So this is how in physics and chemistry we get constants by doing multiple experiments. So if you take different elements over here, their weights will be different, their gram atomic mass will be different, but when you divide them both, you will always get this number. So point is that you don't have to mug it up this number. You don't have to. What my purpose over here was to make you understand that how this number came into action. So this whole thing is 1 mole. 6.022 into 10 to the power 23 atoms are present only in 12 grams of carbon, and this is 1 mole. So if I say 1 mole of carbon has how many atoms? These atoms. 1 mole of carbon will be equal to how much weight? This weight, 12 grams. So we'll do 1 mole. So 1 mole of calcium is equal to 40 gram. That is gram atomic mass of calcium. Mass of calcium is 40. So this is equal to how many atoms? 6.022 into 10 to the power 23 atoms. Just remember, it's only 40 grams. We are talking about 1 mole. So if we take 2 moles of calcium, so this number will also be multiplied into 2. This will be multiplied into 280 grams. So just remember that. Now coming to the formula, number of moles is equal to given number. Now what this given number is there. So the given number can be particles, can be electrons, can be protons, can be neutrons, can be ions, can be molecules, can be atoms. So can be anything, any number, but not number of moles. So what I suggest to my students, specifically in mole concept, that you need to read the question properly. I always say that half of the problem or 70-80% of the problem is solved if you read the question properly and understand what the question is asking. So whether it's number of moles or it's some other number that they're asking. Because if it's number of moles, then you have to calculate this. But if it's number, some other number, then you have to calculate this. This is given by capital N divided by Avogadro constant. So this is given as Na. This is just the capital N. So the formula for this relationship, given number divided by Avogadro constant, this is the second relationship. Now we'll do one question. Before moving to that part, I just want to add a note over here about formula mass. Formula mass is the mass of ionic compounds. We always express ionic compounds like NaCl as a formula unit because of the crystalline lattice that we have. We never call them as a molecule. So for NaCl, for one particular unit, what's a mass? So calculation part of NaCl for calculation of its mass is going to be same as what we calculated for molecular mass. It's not going to be different. But the addressing part is different. We are never going to call it as a molecular mass of NaCl. We are going to call it as a formula mass. So sodium over here is 23 gram atomic mass and chlorine is 35.5. So if you add it, it will give you 58.5 U, or you can write as gram, whatever the question they are going to ask you. Now moving ahead, we are going to understand 1 mole of calcium carbonate has how many atoms, how many electrons, how many protons, how many neutrons, how many ions, how many molecules. So all these things we need to understand for 1 mole. So when it comes to atoms, again if you go back to what I made you understand about the atomicity. So in the mole concept, you are not just dealing with Avogadro number or the molecular mass, you are dealing with the actual number of atoms also. So 1 mole of calcium carbonate is equal to how many atoms? Because we are calculating some other number apart from number of moles. We have to use this Avogadro number always. Since they are asking about atoms, we need to consider the atomicity of calcium carbonate. Only when you're calculating atoms. So atomicity of calcium carbonate is 1 atom of calcium, 1 atom of carbon, then 3 oxygen atoms. So this will give you 5. So into 5, why this atomicity number is essential? Because 1 mole of calcium carbonate cannot be only equal to the Avogadro constant. If they are asking you atoms, you have to multiply the actual number of atoms in its one unit. Calcium carbonate is an ionic compound. So if you don't multiply with its actual atomicity for calculation of number of atoms, then your answer will be wrong. So if we go to the next step, how many electrons calcium carbonate has? So for this, we are going to approach differently. Number of electrons, total number of electrons. So in this total number of electrons, always add the atomic numbers, because we are talking about the neutral atoms. Even in the bonded state, electrons are not leaving the atoms and going somewhere else. They're getting transferred, but the whole entirety of the compound, the whole system, is not losing electrons and changing into ion. It's a compound. So electrons are in between getting transferred, but they're not leaving the compound. So in that case, just add the atomic numbers. That will be much easier. So calcium atomic number is 20. 20 electrons we will have. Carbon is 6. 6 electrons we will have. Oxygen is going to be 8. Please do not forget to multiply with the number of atoms. So 24 plus 6, that is 30. 30 plus 20, this is 50. So we have 50 electrons. Now, if we are going to write this, 1 mole of calcium carbonate has how many electrons? Do not forget to use the Avogadro number. Definitely this is there, but into its actual number of electrons which are present in 1 unit of calcium carbonate, that is going to be 50. Now, if we talk about the protons, so total number of protons. So protons, again same atomic number, 20. For calcium, carbon is 6, oxygen is 8. Into 3, it will give you the same number, 50 protons. So we'll come back, same number, 6.022 into 10 to the power 23 into 50. I'm not multiplying this entire into one number, because I want you to understand the concept. Once we'll do the numericals, then we will get to the one particular value. Then if we go to number of neutrons, so calcium has 40 mass, 40 minus proton number 20, 20 neutrons again. So carbon atomic number 6, mass is 12, 12 minus 6, 6 neutrons again. Oxygen atomic number 8, mass is 16, 16 minus 8, 8 neutrons. So again, even the neutrons coincidentally are same, 50. So 6.022 into 10 to the power 23 into 50 neutrons. Now if we go to the ions part, now again, if we don't multiply the actual ions present in calcium carbonate has one calcium ion and one carbonate ion. We can see it from the formula. Can you see any number at the in the subscript of calcium? No. Can you see any whole something with a carbonate? No. So it's one ion each. Carbonate is a radical, calcium is a single element ion. So total ions are how many? 2. So again we go back. How many ions? 6.022 into 10 to the power 23 into 2. Now how many molecules? Actually, we should not use the term molecules over here because this is the compound, but at least for understanding, we can use it on the theoretical ground. 6.022 into 10 to the power 23, and this whole thing is just one entity, so we are taking it as 1. That's the answer. So this part is something trickier in the student's mind. Whenever they are going to ask you about atoms, electrons, protons, neutrons, ions, molecules, keep these things in your mind, because otherwise the mole questions are always going to be wrong. So let's do one question. Calculate the number of moles in 3.011 into 10 to the power 23 molecules of carbon dioxide. So I'll be proceeding both in unitary method as well as in your formula based. So we'll write like this: 1 mole of carbon dioxide is equal to how many molecules? 6.022 into 10 to the power 23 into 1 molecule. 1 is indicating this entire is 1 molecule. So they're asking 3.011 into 10 to the power 23 molecules will be equal to how many moles of carbon dioxide. So we can take 1 divided by 6.022 into 10 to the power 23 into 3.011 into 10 to the power 23. This is approximately 1, this is 2, so half or zero point 0.5 mole. That's your answer. So if we want to put in the formula number of moles, given number divided by Avogadro constant, they have already given us the number, these many molecules are present, divided by 6.022 into 10 to the power 23. Na stand for Avogadro constant. So again, if we cancel, this is half. Same number. Now till here it is fine. Everything looks easy, understandable, manageable. Everything is smooth. Now, the trickier part comes for understanding for most of the students is when we relate these two concepts. The mass relationship, calculation of number of moles with respect to mass, and calculation of number of moles with respect to number. When we relate these two relationships and we twist the questions and try to ask you something out of it, so most of the students can understand in one go. Sometimes others definitely take some time to understand it. So let's try to understand. Now remember this: number of moles with respect to mass, we did this relationship. Given mass divided by molar mass, this is equal to given number divided by Avogadro constant. Now these are related to each other. Can you see it? I didn't do the third relationship till now, the volume relationship. Even that is related to each other, all these. So what do you understand? You calculate what do you understand by this? You calculate number of moles by this relationship, put it equal to this, and you can calculate anything which is missing. Like if they're asking you, obviously they won't ask you Avogadro constant. They can ask you to calculate if it's a subjective question, but in objective it's they can make a question out of it. Yeah, it can be a little different. Anyways, so they can ask you the number, they can ask you the mass, because this is constant, this is constant. In both the cases, the denominators are constant. So remember, you these both are equal to each other, these four values. Out of these four values, if you don't know the any one, you know the three, you can calculate the fourth one. So given mass can be calculated by taking number and taking molar mass or gram molecular mass or gram atomic mass divided by Avogadro constant. This is one formula. Now, I never focus on memorizing the formulas. There are so many formulas in physics and chemistry. What will you do? Will you memorize all? The percentage of you forgetting some formulas is going to be always higher. Now, it can be if you have a photogenic memory, you can remember all formulas, you can go through that, or you can practice, or you can understand how that formula is made at the first place, or you can understand the concept. So if we need to calculate the mass, if we know the number of anything, electrons, protons, neutrons, we just did, into the gram molecular mass or gram atomic mass divided by Avogadro constant, we can calculate mass. Or we can do differently. Given mass into Avogadro constant, take this over here, divided by gram atomic mass or molecular mass, that will be equal to n. So either you can calculate the capital N or you can calculate the given mass. So these both are related. You're going to understand more when I'm going to do one question. So calculate the number of atoms in 16 grams of sulfur molecule. Now, one thing we need to remember over here, sulfur molecule is octatomic. If you don't consider that, your answer will be wrong. If you don't know the mass of sulfur, it's not given in the question, we will not be able to do it. If we have memorized, we'll have upper chance to calculate it correctly. Now they want to calculate the number of atoms not in any other value of sulfur but 16 gram. So if we see 1 mole of sulfur is equal to what weight? Like, what's the weight of this sulfur molecule? So sulfur mass is 32 into 8. So 32 into 8 will be what? That will be 256. 256 gram. So 1 mole of sulfur molecule is equal to 256 gram. Now if we have 16 grams of sulfur already given in the question, then how many moles are present over here? So 1 divided by 256 into 16. So what's going to be 16 divided by 256? This is going to be 0.0625 mole. So this is our mole that we calculated. Now they're asking number of atoms. We just calculated mole because mole calculation of number of mole is a connecting link between the mass and the number of atoms. If you see this, please remember connecting link. So we calculated moles. Now we are going to do what? 1 mole of sulfur molecule is equal to how many atoms? 6.022 into 10 to the power 23 into how many atoms? We know sulfur molecule is acid into 8 atoms. Now if you don't do this, your answer will be wrong. If you get your number of atoms without multiplying the atomicity with Avogadro constant, that will be wrong. So now put the same number of moles over here because we want the number of atoms in 16 gram. So until unless you don't link the number of moles, you don't equalize the number of moles, you won't be able to get the answer. So 0.0625 mole of sulfur molecule is going to be 6.022 into 10 to the power 23 into 8 into 0.0625. Correct? So 1 mole is this, 0.0625 mole will be equal to what atoms? So we can calculate. So 6.022 into 8 into 0.0625. This will be 3.011 into 10 to the power 23. Right? So these many atoms we have calculated, which is approximately, you can say, half of this Avogadro number, right? So that's the answer. So similar to these questions, we need to practice more so that we can understand it. So we will do that in the next class. I hope you have understood it and you can practice these kind of questions if you have in your textbooks or from online. So we can discuss few more questions related to these two concepts. By mixing these two concepts, we'll do some more questions in the next lecture along with the volume relationship. So thank you for learning along with me.